So I like to usually explain why the words, what they mean, the word damped, and how it relates to what we're going to see today. And this isn't meaning damp like describing if it's kind of wet outside, okay? This is, have you ever heard the phrase like, oh, she put a real damper on the mood? Have you heard that phrase before? What does that mean? She's like a Debbie Downer or a negative Nelly, we used to call them, or a, right? She kind of kills the mood, right? All right. So putting a damper on something kind of makes the mood go down, would you say, right? Okay. How about, does anybody play an instrument in here or a piano and ever heard of the damper pedal? Okay. Here's what the damper pedal does. A piano, what happens is there's a hammer and it strikes the key, and the hammer strikes the string, and the string oscillates. Actually, its sound can be measured by a sine curve. A damper pedal puts like a damper on it, and what it does is it reduces the oscillation of that key or that string. Okay? So damped oscillation, I'm going to just say, is any reduction of the amplitude. Okay, any reduction of the amplitude. That's what damped oscillation means. Okay. Now, in any sine or cosine curve, we saw on the board, not the 2 minus 0.3x, but I said the 4 cosine x. Didn't you guys tell me that it went between 4 and negative 4? So, anytime we have this, y equals f of x times cosine of x, or f of x times sine of x, what happens is that the sine curve is going to oscillate between plus and minus f of x. What we've seen so far is plus or minus f of x are horizontal lines. Isn't y equals 4 and y equals negative 4 a horizontal line? Okay. But we're going to see something really interesting when we change these to not just numbers, but actual equations. Well, I think it's interesting. You might not think it's interesting. Okay. So, when there is a reduction, any reduction of the amplitude, we call that damped oscillation. So I'm going to write here, any reduction of the amp is when we are going to say there's damped oscillation. Okay. So I would like us to take a look at 3 different equations, and then we're going to just leave some space in between them, okay? So the first one that we're going to take a look at on our calculator is f of x equals 2 to the negative x sine 4x. Then let's leave some space. Then we're going to look at g of x equals 3 cosine 2x. And then, again, we're going to leave some space. We're going to look at negative 2x cosine of 2x. Okay. By the way, would you put a box around this f of x or something, or write it somewhere else? When we have damped oscillation, we call that, whatever that function is out in front, we call it the damping factor. Call it the damping factor. Okay, and you're going to see why in a second. Let's graph this one. By the way, let's plug it in. I am going to start with, the window I've been using lately, which is negative 2 pi to 2 pi, scale of pi halves, and then if I need to zoom out, I will. Okay. All right, so I have a question for you. This should be good to you of first semester. What's the function out front? 2 to the negative x. What kind of function is that? Exponential, isn't it? Doesn't exponential growth or decay? Decay, why? 2 to the negative x. So, like something like this? Okay, let's graph it and see what happens. So, it's like a sine curve, but the amplitude keeps getting, as I go to the right, smaller and smaller and smaller and smaller, right? Is there a reduction in the amplitude? Yeah, so we call this damped oscillation. All right, so this is an example of damped oscillation. The damping factor is the function out front. And what did you guys tell me the function out front was? 2 to the negative x. And if you want to see something cool, I am going to go in my y equals and I'm going to do, you remember how I said it's going to oscillate between plus or minus that? Watch. 2 to the negative x and negative 2 to the negative x. Do you see how the amplitude never goes above and below those two things? So that's why it's called its damping factor. Okay. Now the last thing, if it is damped oscillation, is you should be able to describe for me the direction. So as x goes in what direction is the amplitude getting smaller or being reduced? As x goes to, good, what did you say louder? Yeah, so the direction that the damping occurs or the reduction occurs is as x goes to infinity. Okay, hopefully that makes sense. All right, so I have a question or a guess. I want you to guess. Do you think damping is going to occur here? Remember, damping is if the amplitude is going to be reduced. No, why not? Yeah, well, and it actually is an equation, it's just that we haven't thought of it that way before. It's a horizontal line. Horizontal line at 3, horizontal line at negative 3. So if they're always at 3 and negative 3, and the amplitude keeps hitting 3 and negative 3, the amplitude's not going to reduce, is it? So, but let's just take a look, just so we can see it. So 3 cosine 2x. Okay. So now, hey, the sine curve still oscillates between plus and minus f of x. It's just that it's plus and minus 3. However, is there any reduction in the amplitude? No. So we don't describe it in this way because there is no damped oscillation here. All right, finally, let's take a look at the last one. Okay. That's kind of an interesting one. I'm going to zoom out a little more so you can see what it looks like when you zoom out. So here's what I'm going to do. I'm going to change this to, what is it, 2 pi. I'm going to do like negative 4 pi to 4 pi, and I'm going to change this to like negative 20 to 20, so maybe you can see it a little better, okay? Is there a reduction in the amplitude? Yes, it goes down and then it goes back up again, right? So, but there still is a reduction in the amplitude because the height of the waves is changing. So this is an example of damped oscillation. Okay, what is the damping factor? What is the damping factor? Negative 2x. Negative 2x. Alright, so just so you can see how that works again for this one, I am going to put negative 2x, and then I'm going to put the opposite, above we said the opposite of negative 2x would be what? Positive 2x. And then I'm going to graph it. Aha. Okay. So now we can clearly see exactly how those amplitudes are being reduced. So that's the damping factor. What do you think the direction would be for this one? Because it's coming from both ways it's reducing, right? And so you're absolutely right. It is direction as x approaches 0. As x approaches 0. Okay. All right, so hopefully you have